Much different than our prisms and our cylinders. Here's why. Prisms and cylinders, we always had two bases. All right, we always had two bases that were congruent and parallel to each other. Pyramids, one base. One base. That's it. Cone, one base. So there, if you want to know a big difference between what we're doing today and what we did on Friday, that's one big difference. Is there's two different bases, or just one base in a pyramid. There was two in a prism and a cylinder. Here's probably the biggest thing I got to get across for you before we do any problem, and it's got to get done right away. I got to get this across to you, and that is in a pyramid and in a cone, there are two, not one, two different heights. Two different heights. There is an altitude, and then which is the height, and then there's a slant height, which I will go over right now here. Anybody familiar with the whole Mission Impossible franchise? Anybody? Because that's how I'm going to discuss the difference between the two heights. All right, is using something from Mission Impossible here. All right, so we are all going to go inside a pyramid right now with me. We're going to go inside a pyramid. And here's what we're doing. Okay, you guys are going to be at the top of the pyramid. All right, you're going to be at the top, very top of the pyramid. Good? Which is called the apex. Everyone see the tip? Everyone good there? That's the apex. You are right now holding on for dear life of the apex. All right? Because if not, you're going to fall right down to your death. So what you do is you take out of your satchel here, you're going to take out some rope. All right? You're going to hook it onto the apex, and you're going to drop it straight down. There we go. You're going to drop it straight down to the ground, so it's perpendicular. Everyone see this right now. From the apex all the way down. That is the altitude of what I'm talking about here. Apex, straight down so you can slide down to safety in the pyramid. Everyone see this. So sometimes I'll call it altitude. I may misspeak and call it Mission Impossible. That's what it is to me. All right, you're up here on the apex. You drop your rope all the way down. This, everyone see it. This is the altitude, the height I'm talking about. All good. Okay, so what's the deal with the other height? So let's draw this in. Perpendicular down to the base. Make a little note. That's my altitude. Now, what's the deal with this slant height? You guys that were here on Friday, I told you every polyhedron has vertices, edges, and faces. And we all went over what a face was. The slant height is the height of one of the faces. So if I take one of these four faces now, everyone see that? That is the slant height. Please see the difference between the two. Height, altitude, drop down from the apex. That's your Mission Impossible height. Slant height is one of the heights right on the faces. All good. You'll notice now I have two sides of what we're going to form of a right triangle. All right? Because I will not probably be giving you everything. You're going to have to find the actual height. And we're going to do that using Pythagorean theorem with this right triangle here. Questions between the altitude and the slant height? Let's go formula now. It is different than prism and cylinder. Turn to the back of your packet, please. We added a little fraction onto the formula, didn't we? Now for a pyramid, yeah, we're still going to do capital B times H, but the big part, now we're going 1/3. Reminder, since I know we had a lot of heads out on Friday, capital B is what? Area of the base. And I will let you know, in any of the pyramids we do, assume the base is regular. Okay, assume the base is regular. H now is, right? I'm going to say height, but we got to make sure we know which one we're talking about. We're talking about the altitude, guys. That's not slant height. Okay, that is my Mission Impossible height. Apex, straight down. That's what the H represents. Okay, so my yellow segment in the diagram up top there. All right, everybody good? Questions before we find the volume of a pyramid? Go ahead.
What if we have the slant height and not the altitude?
Well, we're going to talk about that right now in number 1, right? Any issues? All right, here we go. Find the volume of this pyramid straight up here. So I go to my formula sheet, 1/3 BH. Let's talk about the area of the base with somebody in this class now. Let's talk. Remember, any base we assume is regular, so we're looking at a square here, right? How do you want to find the area of that base? Shroom, talk to me here, going up and down quick here. Kara, how do you find the area of that base?
You do 10 times 10.
Okay, 10 times 10. There's capital B. All right, there's capital B. Now I'm ready for the height. But unfortunately, what's the 13 pointing to? That's slant height. let's draw it in. I need the Mission Impossible height, the altitude. I need that bad boy. So what we do is, we're going to connect it with the slant height to make a right triangle. I only know one side, but I'm going to show you guys how to find the other side. Everyone see the other leg here? Not the height, but the other leg. That's always half the base side. All right, that's always half the side of a base. Always, always. I think I might have, did I put it up there anywhere? Yep, endpoint as the center of the base. So we go over, this is going to be 5. And now you tell me how I'm going to find it. All right, well, using what to find the Mission Impossible height now, Abby? Pythagorean theorem. Where's the 5 and 13 go, guys? 5 and 13. John, where's the 5 and the 5 go?
5?
Yep.
Oh, okay.
And then for A or B, and where's the C go?
Wait, let's see.
I'm sorry, where does 13 go? In for C, yep. When you have that height, let me know. When you have the height, let me know. Aylin, when you have the height. 12. And that's the height I want. I do not want slant height. I want the altitude in there. And we end up with 400. I'm going to keep repeating myself, so sorry if you were here on Friday, but if you weren't here on Friday, I still don't care about units, but if you are putting them on in volume, the units are always cubed. That's how I know I'm doing volume. The units are always cubic units. Questions? That's basic, right? We always go over one basic question to find the volume. Now we get a little bit more serious and detailed. Honors like. I got a regular pyramid with a square base. I don't know if anybody wants to try to draw that bad boy out, but mine's not going to be great. I can tell you that. There we go. Square pyramid. The perimeter of this base, perimeter of the base is 36 inches, not the area, the perimeter. And the height of the pyramid is 15. And this is the question I always get. What are they talking about? The altitude or the slant height? If I wanted slant height, you know what I would write? Slant. All right. So if you don't see the word slant there, we're talking about the altitude, the height. All right. If I want slant, I'll write the word slant there. So we got 1/3 BH. I got a problem though. I do not know any sides of that square, but that's where the 36 comes into play. All right, so find me a side length using the 36. Where am I going with this one? Too many kids. There we go. Chia, what do you want to find the side length? Divide by 4. Yep. So divided by 4, that gives me a 9-inch side length. So So what am I going to put in for the area, capital B here? Aylin, the area of that square?
81.
81. 1/3 of 81 times the height, which was already given, 15. Yes, Connor.
So we assume that they're talking about altitude if they just say.
I will write the word slant in.
Okay.
Okay. I will the book will have the word slant.
And the regions will do the same.
Correct. Yes. Or it'll be drawn in like number 1, and you have to know that's the slant height. How's 405 cubic inches? 405 cubic inches. Good to go. Any issues? I'm not impressed that you find volume. I'll be more impressed if you can find something maybe on that side now if you know the volume. Okay, that's what we have to work on now. And to do that, we got to take a little quick virtual field trip to the Great Pyramid of, what do we think? Giza? You guys study this, don't you? Giza.
I've never heard somebody say that.
Giza. Okay, I guess we'll find that out after we do the problem. Wow, how about that volume, huh? Almost 2.6 million. A height, again, it just says height. Is that the slant height or not? No, I will write the word slant in there. It's the height, 146. What's the length of one of the sides of the bases? Whew, we got work to do here. All right, my Great Pyramid here. We know the volume and we know the height is 146. Boom. .5. And what's one length? One side of the base. One side of the base. All right, so we're given volume. So I go to my formula for a pyramid. 1/3 capital B times H. I plug in my 2.5 and change million there for volume. Looks like I'm going to be solving for big B, huh? Because I already have the height of 146.5. So it looks like, remember, keep in mind what capital B means, because I'll be asking that in a minute when we solve for it. Before I ask for it, though, is that going to be my final answer, capital B?
No.
Nope. So you guys have a nice little number on your calculator right now that we're not going to round. And that should be, what do we got? 53,084.15017. If anybody's wondering how we did that, I multiplied both sides by 3 to get rid of the 1/3, and I divided both sides by 146.5. Any questions getting there before I move on? All right, what did we just find right there? What's that capital B telling us? Not one side length, but Lucia, what's that finding us? That's the area of the square base. The area of the square base is 53,000. But I need to find one side. What do you know about the sides of a square? They're equal, and I do length times width, don't I? All right, length times width. So over here, x times x equals that 53,084.15017. Question, Connor?
No.
Okay, I got a call on somebody here. Everyone's good there? How I'm getting to one side. Length times width, they're both the same. I keep going. I don't get 2x. I get x squared equals 53,084.15017. And then now, how do I solve for one side of the base here using this, Theo? No, you didn't. Refocus. What do we got here? How do I get rid of the squared? I what? Relax, Theo. Relax. I'm just asking a simple question. What do you do on both sides? Take the square root. And then one side to the nearest meter when you have that. One side to the nearest meter. Finish this up here. Test, finish it up. 230 meters. This is, if you are using units, this is not cubed, right? I'm just finding a side length, so just regular meters. Not cubed, not squared. We're good. One mistake I do see, a lot of kids will take this 53,000 and divide by 4. Sure, if it was the perimeter, yes. Okay, so know what you're finding. All right, this is the area of the base, so that's why I went length times width and not divided by 4. Questions? With the pyramid before we go cone. Zach,
If we're doing perimeter, we don't have to do the X's, right? We can just take the number and divide by 4.
if you have the perimeter, yes. But when you're solving in this formula, remember capital B is not perimeter, it's the area of the base.
Oh, yeah.
That's area, not perimeter. Any others about pyramid? All right, cone. Hate to disappoint you, but I'm not going to get up on any desks to do cone. Cone is a height. There is a height and a slant height. Height, same thing. Top of it, drop your rope. There's the height. Now you'll notice for a cone, there's no faces. Right? There's no faces. So that means my slant height will actually be right there. Since there are no faces to draw height in. And you guys can tell me this. I connect the two with a radius. Good. That's how I form the right triangle in a cone, with the height, radius, and slant height. That's how it's done. And go ahead. Go back to your formula sheet, please, everyone. Go back to your formula sheet. Let me know what a cone is. And breaking news, this is why we do cone and pyramid on the same day. Volume of a cone according to your reference sheet there. Lucy?
1/3.
Yep. Everything still needs the same. Hey, that's what your reference sheet gives you. But since we're in honors, how about a little bit more detailed one? Can anybody substitute anything in for capital B? What is always the base of a cone going to be? A circle. So if you want, this is your call though, because it's not on the formula sheet, you could substitute in the area of a circle, pi r squared in for capital B. All right, I'm going to do how many here with you? 2, and then we're going to have a group challenge here. Group challenge. Hopefully you trust everybody in your group. Here we go. First cone. Leave your answer in terms of pi first. So 1/3 pi r squared times the height. Hopefully we know what the 15 and the 17 are referring to. If not, we'll go over it. The height is given there. Which one you pulling out for the height? 15 or 17 there? Which one we pulling out for the height? Theo, which one is the height? 15, good. What is not there is your radius, which we'll have to do Pythagorean theorem for. Okay, we'll have to do Pythag to find the radius. First, though, I need to know where the 15 and the 17 are going before you get there. So let's go, Henry. Where's the 15 going?
For A.
Yep. How about the 17?
C.
All right. And then we got to solve for our radius. So I'll let you guys calculate that and ask somebody. And using Pythag, what'd you guys get for your radius length using Pythag? Here we go, up and down. Violet, what'd you get when you have it? 8, good work. Again, part A is asking in terms of pi. And you guys will get lucky because your calculator just does it for you, right? Remember, in terms of pi, we need pi in your answer when you have it. Pi in your answer. Pi in the answer for me there. You just think I just went there, so I would know, but probably not. Lucy, when you have it.
325.
320 pi.
Yeah, these are the two.
1/3 times pi times 8 times 15.
Yeah,
Eight
it's
squared.
8 squared.
8 squared, yeah, that would help too, huh? So go ahead again, because I didn't have 8 squared, so mine's obviously wrong.
320.
320, good job, pi. Meter squared. I'll look like a genius, though. Period. And then part B now, go ahead and round it to the nearest tenth. I'm going to have to trust whoever has it here. All right, I'm going to trust you. Scott?
1,005.3.
Looks good. If I do 3.14 real quick then. Yeah. Go ahead, Kara.
Should that be meters cubed?
It should be meters cubed. Yep, there we go. I got rattled. Didn't have the right answer on mine and got rattled. All good so far. All right, I should stop the film and just redo it 8th period, but great ones make mistakes, so we're going to keep it there. Next up, now I'll give you the volume. What's the diameter? What's the diameter? My formula does not have D there. So how am I going to be able to accomplish this? Well, it doesn't have diameter, but it does have radius, which will lead me to the diameter. So the plan here, solve for the radius, double it at the end, and you'll get your diameter. All right, 96 pi. That goes in for the volume for V. 1/3 pi. We already said we're solving for the radius. The height of the cone is 8. That's the one we want. What do you notice on both the left and the right? That eventually we're going to have to move and we'll cancel each other out. Pi. Now, hey, I want to warn, that's not automatic. That's not automatic. It's got to be on both sides of the equal sign here. All right, both sides. I forget where I saw it, but there was a problem somebody did where there was 2 pi's on one side and 1 pi on the other, and they thought they could cancel out all 3. You only can cancel 1 with 1. Okay, and they have to be on opposite sides. Maybe it was on somebody's area quiz. And then from here, you can multiply 1/3 and 8 and get rid of it. You can get rid of the 8. You can get rid of the 1/3. I don't care what you do. You're going to have to do everything eventually, so. Should get, what, 36 for r squared?
Yeah.
Radius length is 6. So we end up with diameter of 12. If you guys are putting units, it's just going to be centimeters. Nothing squared or cubed because we're talking about radius. All right, any questions before we go on to the challenge here? All right, here's where we are now. Now you have 4 polyhedrons. All right, and again, I don't care if you were here Friday or not. We got prisms, we got cylinders, we now have pyramids and cones. All right, and you'll notice our notes is just not the same all the time. I want to reintroduce and review the 2 that we just did. All right, with cylinders and prisms. So please don't forget those formulas. They're on the formula sheet. So up next is, all right, we all have the ability to find volumes of one object. Now I want to do something with it. Just like area, what did we do with Big Al? We sealed his darn deck. We put wood chips into the shaded region. All right, I want more than the volume now. I want you to do something with it. And that's what you're going to do in your groups right now. All right, this first problem involves a cone filling up a cylinder with water. How many of those cones can you put in without overflowing? And then the second problem is going to be a prism and actually 2 prisms, I believe. And you got to figure out how many units, British thermal units, it's going to take to cool the house. So you and your groups right now, I don't want to be called over until everyone is done and everyone agrees on the process and the final answer. Call me over, I'll check your work, then we move on. Okay, then we move on. All right, so talk it over in your group. You're going to have to, I didn't want to do this as a full class. If you're watching this at home, try it out yourself and then show it to me when you get back in class. If you're watching this video at home, try it out yourself, show me the answers in class.